Alright, so in this video we talk about what we know by the name scalar and what we know by the name vector. Basically, in physics, we try to work with quantities that have a magnitude, that just have a magnitude, or would have a magnitude, as well as a direction. Now, there is a requirement of a direction at times, and at times there isn't. And the reason is because at times we're working just with quantities in which magnitude specifies every single detail in terms of that attribute of the particular body we're talking about. For example, if we consider a feather, right? Here's a feather, a yellow feather here, and we're trying to weigh it on a scale, right? This is a supposed scale, and we know that the scale points to a particular number. We try to read it out, and it comes out to be, say, 5.6 grams. Now 5.6 grams, or just 5.6 small g right there, is the weight, is the mass of the feather. And because it's the mass, and the fact that it's just giving us a number at this point, and hence just the magnitude, we would try to question us, do we need a direction in order to fully understand what the mass of this feather is? And the answer is a clear no, because everything has a mass, and it doesn't depend in which direction we are measuring it or in which direction that mass is acting. The mass doesn't need a direction. But every quantity in physics is not really that identical to as what mass is of a body. Many times we need a direction as well. For example, if we know that a car, well, here's a car, but a car is moving in, say, a particular direction, say with a speed of 20 kilometers an hour, in the direction of northeast, then we know that the speed is given by the number, and that is what we call the magnitude. So the magnitude of this car's motion is 20 kilometers an hour, which tells us how fast the car is moving, how strong is its movement in that sense. And the direction here of northeast tells us, well, if this is north and this is east, like so, south here and west here, then the car is moving in this direction. It's not moving in this direction or in this direction, it's moving exactly in the northeastern direction. So that helps to define which direction the car is moving. And that comes in handy, say, if you're talking about two cities, say city A and say city B, right here. In this case, city B is located to the north of city A. So if we had a car which started at city A, moving with 20 kilometers an hour in the northeastern direction, then at no point in time would this poor car reach city B, for it will be moving in this direction, and this direction does not terminate anywhere close to city B. So that really helps in terms of determining how the car is moving, in terms of determining, in more proper words, I would say the dynamics of the car. Now, if we had another car, say, like say a green one here, which were moving in the northern direction, then say with a velocity of 30 kilometers an hour in the northern direction, then this car would reach B. And so by that, it differs from the dynamics of the first car. It also differs in another attribute, which is the magnitude of this quantity that we are calling velocity. This car here is moving much faster than car A because it's moving with 30 kilometers an hour as its speed, whereas the original red car was moving with just 20 kilometers an hour. So we see here that at times we do require direction in addition to magnitude to define certain quantities in physics, and those quantities are what we call as vectors. Now that we have discussed the importance of directions in addition to magnitude for many quantities in physics, we can work out certain quantities that we may or may not have come across so far, and we try to work out the fact that which of them are scalars and which are vectors. So let me rub this all for a moment, and let us start with mass, right? Mass is something that we've already discussed, and mass only needs to have a magnitude, and that's all that we really want out of it. Say something like 10 grams. So mass only needs a magnitude and hence is a scalar. Whereas what we discussed right now was a quantity called velocity. velocity is speed plus direction. And by that virtue, it becomes a vector because we have a magnitude and we also have a direction. And hence, like I said before, it's a vector. Another quantity could be something like force. Now, force is a push or pull that you end up feeling by an action of something. For example, if you're sitting on a chair, right? If this is your supposed chair and you are sitting on it, like so, well, the chair ends up supporting your weight, and it does so by applying some sort of force opposite to the force of gravity. That means against the force of gravity, and that is what we call the normal force. If we ignore the details, we should really consider just the fact that there is a force that the chair applies on a person sitting on it, and that is what stops you from falling onto the ground, right? And that force is what we call the normal force, but the force has a direction. Like I said before, it acts opposite to the direction of gravity. And gravity, as we all know, points downwards, because if you leave something, say like an apple, as what Newton did many years back, it ended up falling down. So, by that, we know that force is a quantity that has a magnitude. That means if the larger you are, the more weight you have, the more stronger the force you may experience when you're sitting on the chair. But it also has a direction, and the direction is against the force of gravity. So, by our definition of what a vector is, force clearly satisfies the condition of being a vector, and hence should come under the list of a vector. Now, let's talk about something as another quantity. Let's talk about the quantity temperature. If we try to get rid of this before we move on, well, temperature tells us how hot or cold things are. If we have a beaker of water here, right? Now, the beaker is containing H2O, normal H2O, or just another quantity. But we can also have H2O, water, in the form of ice, and that's a solid block of ice. Looks like butter, rather. Anyway, this is ice. Now, if we try to touch both of them, then this seems kind of lukewarm or a little bit cold, maybe even a little bit warm. And we attribute that by saying that the temperature of this beaker of water is normal, or we could say it's greater than the temperature of ice, because if you try to touch ice, it feels very cold. And at that point, we can say the temperature of ice is very low compared to the temperature of water. Therefore, even though I've drawn temperature with arrows here, that shouldn't confuse us. You're only talking about the magnitude of how hot or cold something is. And by that definition, we should only look at temperature as if scalar, for it doesn't require a direction in which we measure the temperature, and so must come under the category of a scalar. So here we have temperature, along with mass, and is a scalar. If it also helps, temperature is measured in kelvins, or degrees Celsius, or even degree Fahrenheit. And those are just different quantities in which we try to measure how hot or cold things are. Ignoring that a little bit, we can move on to another quantity which we call speed, right? We've already discussed that velocity has speed and direction hidden in it, and speed is something that relates itself to the magnitude. So if you try to tell you that there is in an animal, like a small bug, like so, which is moving very fast, and the bug moves with a speed of, 15 meters per second. This is what we say that the bug moves with. Many researchers might have studied this little bug, and they say that the bug can move when 15 meters per second. It's a very high speed for such a small animal. At that point, we're talking about the speed of the bug. We're really not concerned within which direction the bug is heading, but we're really talking about what its speed is. And by that definition, we're only talking about the magnitude of this property of the bug's motion. And by that, we mean that speed has everything to do with what we have already defined as a scalar, and hence must come under the category of a scalar. So here I'm writing speed like under the category of scalar, like I did with temperature and mass. So here's a key point. Even though velocity includes what speed is, but it also has a direction. By that, it changes the type of quantity. But speed, on the other hand, is something that only values magnitude. and so it doesn't really care in which direction we are moving as long as we know the magnitude. So that was it. There are many other quantities that are scalars and vectors, but so far we have divided all the physical quantities into two categories, scalars and vectors. The first quantity is something that only considers magnitude, and the second considers a bit more, that it considers magnitude as well as direction to define itself in its entirety, and that is what we call a vector. So I hope this video helped, and all the best.